Begin chapter 2 in our Discovering Geometry textbook. And chapter 2 talks about reasoning in geometry. So we are going to introduce the concepts of inductive and deductive reasoning and how we use this when we are applying it to geometry and also to just everyday life. Not just everyday math, but everyday life, how we use reasoning to help us. So the objectives for this unit will be to perform geometry investigations and make many discoveries by observing common features or patterns. Use our discoveries to solve problems through a process called inductive reasoning, and use inductive reasoning to discover patterns. Learn to use deductive reasoning, and learn about vertical angles and linear pairs. So we'll start making some conjectures that we're going to put into our notebook. One of the things I recommend highly, it's absolutely essential that you have to do, so it's not even a recommendation so much as it is a requirement. In your math notebook, you need to start a page of what we are going to call conjectures. And we're going to add to them some very famous, necessary geometric postulates and theorems and just statements that we are going to use to help us in later solving problems when we need to have proof. All right, the first lesson we're going to start off with is inductive reasoning. So a very non-exciting title slide there. So let's get into the first one of information. So what is inductive reasoning? It's kind of a strange term for us. Inductive reasoning is the process of observing data, recognizing patterns, and then making generalizations about those patterns. Now, I put a picture of a bicycle on here. You've been using inductive reasoning probably most of your life. It's how you learn things. You observe people doing it, like when you're learning to walk. You see the adults around you, your siblings, the people around you who are already walking, and then you learn, if I stand up, if I move forward, all right? You start recognizing how to walk. Same thing with how to ride a bicycle with using the pattern of pedaling forward to go forward and things like that. It's also used often by scientists, investors, and business managers. They look at the past and analyze what's gone on historically to help determine what is most likely to occur in the future. So those of you that are very interested in a career in investments, even though we always say in investments that the past is no indication of the future, by studying the past and seeing certain trends and certain cycles, you can start to make some pretty good assumptions about what will most likely happen in the future. Of course, then we don't know. There are always the new things that we can't predict, but there's a lot of things that we can continue to predict. So we use inductive reasoning that way. Now, when we use inductive reasoning, this process of observing and recognizing the patterns and then making generalizations about those patterns, when we use this inductive reasoning to make a generalization, that is called making a conjecture. So let's take a look at an example of how we can make a conjecture. So in science, so let's say a scientist is dipping a platinum wire into a solution containing salt. Scientific name, hopefully you know from chemistry already, sodium chloride. Passes the wire over a flame and observes that it produces an orange-yellow flame. All right, so it makes this nice, pretty flame. She does this with many other solutions that contain salt and find that they all produce an orange-yellow flame. Oops, typo there. I have to remember that to fix for next time. Where did I go? There we go. So, anyways, dipping the salt in the solution, all these solutions contain salt. When they are introduced to the flame, to the heat, they produce this orange-yellow flame. So what conjecture can we make about that? Well, one thing we can determine is if a solution, notice this is a solution, not a mixture. So again, scientific words at work here. So if a solution contains sodium chloride, since that's the scientific term for it, so if a solution contains sodium chloride, then it will produce an orange yellow flame. Now there's a lot of science that goes into why it's orange, yellow flame versus a blue flame or a red flame or any other things. It has to do with the heat. But you can also always ask your science teacher to explain it more. But notice some characteristics about this conjecture. We are saying if a solution contains sodium chloride, then it will produce an orange-yellow flame. So we have this phrase here, if, oops, I did not mean to do that. If and then. If such and such happens, then such and such will follow. That's what the conjecture is saying. If it meets these characteristics, if it meets these patterns, then it will produce this result. So that's the idea of the conjecture. I have to watch holding the pen so I don't make that weird little line again. All right. Let's move on to the next slide. All right, patterns. So how are we going to use this somewhat in our mathematics? We have a sequence, 2, 4, 7, 11, so on and so forth. So we want to make a conjecture about the rule for generating the sequence, and then find the next 3 terms. So when we're looking at patterns, one of the easiest ways to analyze a pattern is determine what are we adding or subtracting to the number. If the number is getting bigger, we know that we're either adding something to it or we're multiplying it by something. So let's try adding and see if we can find a pattern first. If we don't find a pattern, we can always come back and try multiplying. So 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 4 is 11, dot, dot, dot. All right, now there is a pattern here. It's not necessarily that we're just adding 2 every time, but we do see that when we're adding the next term, we will add the next counting number. So the conjecture I can make is that if I add the next counting number, then I'll get the next term. So, continuing on with that idea, if I say 11 plus 5, that would be 16, and then 16 plus 6 is 22, and then 22 plus 7 is 29. So the next 3 terms would be 16, 22, and 29. So I've used inductive reasoning to find a numerical pattern so that I can then determine the next terms. Now that's it for this particular lesson on inductive reasoning. In the future, we're going to have some more examples of how we use that, but a quick intro into it.